All right, continuing with the rotation of this triangle, we just rotated B 90 degrees around point A. So yeah, so this angle would be 90 degrees and B would be the same distance as it was originally. It was 5 diagonal kind of squares this way, 90 degrees in another direction is this way. Okay, and then we gotta do the same thing. Oh no, we're done. That's all 3 points of that. So we connect the dots here, and the new triangle looks like this. And that shouldn't surprise you. Like, A isn't going to move. A equals A prime, because A was the center of rotation. Or rotate it, and it doesn't move. It just kind of twists in place. You can think of it that way. This triangle was kind of facing this direction. When it moves 90 degrees, will kind of face that direction. Like a pinwheel blade moving 90 degrees, holding it here. That, again, shouldn't be too surprising. Oh, what happened to B? B went to point -5, 5. You know what? Well, I want to add something later. Let's first do this this clockwise one. I'll do this one in purple. Okay, so we're going back to triangle ABC, the blue one. Rotate it 90 degrees clockwise, so it's going to stay the same. It's going to stay congruent. It's just going to go 90 degrees this way. Again, point A doesn't go anywhere. This is also A double prime. Let's do C first. C is 5 away from A, so it's going to stay 5 away from A. It's going to go on a little circle trip, and it's going to go 90 degrees down there. That's C double prime. B is originally here. This angle, this direction has to change 90 degrees. So we get angle B double prime to be 90, and B is that far away. I've done this before, and it looks like it goes right about there. Okay, so when I'm done, the triangle looks like this. That, again, shouldn't surprise you terribly too much. This whole triangle just went that way 90 degrees. C double prime, so A stayed in the same place. A is still at 0, 0. B in that scenario went here to 5, -5. And C went to 0, -5. I think it's kind of hard to see what's going on with the coordinates, because now we're supposed to do like the pattern, like what happens to X, Y. It's kind of hard to see when all the coordinates are either 0s or 5s. It's hard to tell, like, what really happened here. Did that just turn negative? Well, no, it didn't. Let me add one new point. Let me add a new point so we can kind of see what's happening better here. I'm going to add a point D right here. Point D is at, so I'm going to expand this table a little bit. We're going to add more stuff to it. Point D started out at 1, 4. Where does it go in under a rotation of 90 degrees? Well, if I rotate that 90 degrees, it's over here 4 and up 1, so it's going to kind of go right here. It's like one square in both directions from C. Remember, the picture has to remain congruent to itself. So now that I have this whole triangle and I see how the whole triangle moves 90 degrees this way, if I put point D right here inside the right angle, it rides along. It's going to stay in the same place, right? Because this figure has to be overall congruent. So D prime, because now I'm going to get numbers that aren't just 5s and 0s anymore. I get a little more interesting stuff to track. So this is -1. Oh, you know what? I wrote my original coordinates wrong. Yes, kids, even sometimes now teachers make mistakes. All right, so that wasn't right. That was 4, 1. That really would have messed us up had I done this wrong. Okay, so this is 4, 1. 4, 1 changes up here to -1, 4. And where does it go in purple? If you think about D double prime, it would have to be right here in the picture. And that's 1, -4. All right, now I think it's a little easier to see the pattern when we talk about these 1s and 4s. And then we can use these other ones to check and make sure that it actually worked. So what's going on with X, Y in the top row here? Well, again, I like this one the best. The number that was Y went to the first coordinate and became negative. So in other words, the new first coordinate is the opposite of the old second coordinate. And this X just kind of went there. So what's really going on here in a 90-degree rotation is that the old XY turns into new -YX. So did that happen here? Well, yeah, but it's hard to have come up with this pattern here because nothing really moved. Here, yeah, this X went to the end, this Y went to the beginning and became negative. Again, it's hard to tell that that's happened and that this didn't just become negative, but this fits with my rule down here, so great. And here they switched places, that's good, and this one over here became negative, good, kind of invisible, but it's also true, it's in keeping with that. I think that's why this is kind of more important to see it this way. The other one, from the blue to the purple here, what happened? Well, the old Y coordinate just went to the first spot, and guess what? The other thing, when it traded, became negative. Did that work with all these purple ones? Yes with 0, 0, 5, 5, yes. This 5 went to the end and became negative. This 5 just went to the beginning. This 0 went to the beginning, yes, and this 5 went to the end and became negative. Great. So here's a couple more rules to file away. All right, so what's going on here? If we're using the transformation of 0 to 70, or sorry, O to 70. O to 70 is the same as this one, right? That's the same as a 270 degrees positive, and that's the one that does this. I'm just going to write this down on the next slide here. This is the one that takes x, y. Just remember what that does, because I don't have it on this page. And it takes it to y negative x. We're going to fit in here. Yeah, okay. That goes to y negative x. So this point, we're starting with p. We want to find the image of it and the pre-image of it. So it's almost like we're saying, all right, so here's the point p prime, and it's the middle one in this sort of three-step story. What did p have to start out as to become that? And then for the oh wait, I think I did that wrong. That's not the order in which these are being asked. The first question was, what happens when we move that? We move that to p prime, p double prime. Where does it go? And the other question is, where did it come from? If it was under that same rotation, where did it have to come from to land where it is at 2, 4? Now you could draw this if you want. You could also just do the rules. I'll do the rule way first, and then I'll draw it, and I'll see if it makes sense. All right, so this 2, 4 is got to go to, it's got to behave under this transformation. So they switch places, and the second one changes signs. So same thing here. This would have had to, this is the result of that same thing. So they would have had to have started out in opposite locations. And this one, when it goes over here, is the one that changes signs. So it would have had to start this at -4 to end at +4. Let's draw this to see if this kind of makes sense. Or you could have drawn it first. There's nothing wrong with that. Sometimes you have to do it that way, so it's fine. So p prime was at 2, 4. I could have done this with real graph paper. It might have been a little bit nicer. There's p prime. P, we're saying, was at -4, 2. Does that look like, if I rotate that, I'm going to call this -90 instead of calling it positive 270. Does that look like a 90-degree rotation clockwise? Yeah, it does. To get from p to p prime, great. And then we say we rotate p prime, it goes to p double prime, which is down here. Does that also look like 90 degrees from there? Yeah, it does. And remember, this is the center of all of it. This rule only works with centers at the origin. You notice that? All of these were centered at A. When you're centered at A, this could maybe have been at A, but centered at the origin is when these rules work. If the center was somewhere else, these rules go out the window. So be careful of that. This whole coordinate flipping and negative stuff is great when the center is 0, 0. If it's not 0, 0, you got to kind of just go to the graph paper and find it under the rules of how do you do reflections in the first place, which is this. Make sure that the radius stays the same and the angle turns out the way it's supposed to. Okay, back to where we were. Okay, so this could get way out of hand really fast. Like you start having centers all over the place. You start having weird angles like 37 degrees. This gets really complicated. So we're going to simplify your life by really just doing this. We're going to do mostly on the coordinate plane. Actually, only on the coordinate plane. We're going to make you do ones that are 90s, 180s, and 270s. You could also, of course, think of this as -90. I kind of like thinking of this as -90. That forces me to think about direction. This is counterclockwise. This is clockwise. This kind of doesn't matter. Anyway, just like we did for reflections and the rules about reflecting over the axes, we got some nice shortcut things that happen to the rules when you're talking about coordinates. Here they are for these three. So for the for the counterclockwise 90, what happens is the coordinates change places, and the old y, when it moves to the new x, it becomes negative. Let's talk about this one next. That same kind of thing happens in the -90, but it's the other one that becomes negative. Notice in the 180, they don't switch places at all, but they both switch signs. Remember how I kind of think of this as it's almost like a reflection? It was like a reflection in one point because it feels like you're measuring towards this point, and then you just keep going the same direction, same distance, like on the other side of it. And with reflections, they didn't switch places, they just turned negative, but one turned negative with y's and one turned negative with x. This is like doing both those at the same time. It's kind of like two reflections. And we'll talk about that in a later lesson, why it is really like two reflections. I don't have a really good way to remember which one of these is which one of this goes with which, like the negative yx and the y negative x. Why is this one 90 counterclockwise and why is this 90 clockwise? You're just going to have to study that and remember it, or keep referring to this page of notes. All right, transforming an equation. There was a question about transforming an equation at the end of the homework for reflections, but we never really did it in the notes. Here it is in the notes for this rotation. So we're going to 0, negative 90. Again, I have to remember which one that is. Negative 90, this is the one that takes x, y's and puts them at y negative x. So let's just remember that. It takes any one of these coordinates and it puts it at y negative x. Okay. So again, for example, what that would do would take points like, let's use 0, negative 1 because that's on our line here. 0, negative 1, when I rotate it negative 90 degrees, it becomes 1, 0. If I had another point, let's get another point on this line. We'll refer to these later, but I'm just reminding you how this works. The point, 2, 9 is on this line. 2, 9 is another pair of numbers that makes that work. When we rotate 2, 9 under these directions, it becomes 9, negative 2. We could do this all day. That's not the question. The question is find the equation of the line. All right, so it was, the pre-image line is y equals 5x minus 1. What we're doing here is the x's and y's transform. The old x is the new y. Let me just write this right here. The old x becomes the new y, and the old y becomes the new negative x. I can just rewrite the rest of this equation in the same place where it was, and actually I could stop right here. And that's an equation of the new line. This isn't a very standard form equation of the new line. I could change this to standard form if I really wanted to. I would rearrange this so that it looks like y equals mx plus b, perhaps. Dividing by negative 5, this would look something like that. So that's a little maybe more standard way to do it. But that's all I had to do. There's people who are nervous by doing it that way, would rather do it kind of this way, and this is fine. I just located, this is why I showed you this. I located 2 points that are on the new line. So all I need to do is find an equation of that line that contains those 2 points. You did this all throughout algebra, maybe even pre-algebra. We're going to try to solve it for a y equals mx plus b kind of thing. Again, this is extra work. If you could really stop here, but if you like this way, it's okay too. I could need to find slope for this. Okay, slope is the subtraction fraction. I have points like 9, negative 2, and 1, 0. Did I do that right? See, there's a lot of ways you can mess that up. I think I did that right. This is negative 2 divided by, I think I did that wrong. What did I do wrong? Something seems wrong here. What is it? Negative 2 divided by 8. See, I've already got a different slope than what I was supposed to get. Let me think about this. I know what it was. I messed up. This point wasn't supposed to be on the line. The point 0, 1 isn't on the line. The point 0, negative 1 is on the line. So that changes things. Put 0 in here, you get negative 1. You silly. Okay, so negative 2 minus 0, 9 minus negative 1. This only works if you do it right. Okay, so negative 2 over 10, which is, guess what, negative 1/5. That looks like more like what I expected. Okay, great. Then if I had to figure out y and b, I have to figure out b, you can put a point in for x and y and figure out what b is, so I'll use the second point. Negative 2 equals m x plus b, and I can solve this for b. This is negative 9/5. This is negative 2. That's negative 10/5 plus 9/5. I'm going to get 1/5. So guess what? When I find the m and the b in here, this m and this b make the same equation anyway. So yeah, I get exactly the same equation this way. Y equals negative 1/5 x plus 1/5. So that's kind of a longer way to do it. I don't know if this feels more safe for some of you, but this also works. You could kind of do a hybrid of the two methods too. If you want to ask about that in class, I could show you. Okay, totally different skill. I'm out of time. I got to do this one last tiny part 3. Okay, see you there.